My name is David Green. I'm one of the Micromatic draft training instructors. We'd like to go over some things today on current draft system status, about the equipment, and possibly the reopening guidance here for parts and pieces and cleaning if needed. As I mentioned, my name is David Green. I've been with Micromatic since 2001. Part of the training group since 2006 as a course instructor, doing all kinds of training that we do here at Micromatic, 3-day training, on-site training, cleaning, every part of the draft business here. We would be able to do that. So we're going to go over some information here. We're going to try to keep it to about 25 minutes or so with questions at the end. If you do have any questions or comments during the presentation, please select the chat feature on the top right of the screen, and we'll do our best to answer them at the end of the presentation. With restrictions being lifted or relaxed in many states, we want to talk about bringing draft beer systems back online. Not only get the systems up and running properly, but so the products that we're dispensing are as good as they can be. So once we do get customers coming back, they want to keep coming back as well. So based on the system being shut down or left as it was, what happened when the shutdown hit? Did we just leave it as is? Did we mothball it? What did we do to the existing system? So we're going to point out some different parts and pieces, components that may need some attention, or maybe just some TLC to do that. We're going to cover the existing system parts, pressure parts and pieces, beer components, system cleaning principles, best practice, industry standards, best practice for cleaning these systems. There is actually a deep clean process that we'll talk about if needed as well. And again, questions towards the end, if we have them, we'd be happy to do our best to do that. If possible, any of these systems that we're going to start up, if there was a few days before opening, that would be great to analyze the system, take care of anything that needs attention, possibly replace parts and pieces if needed. I have a feeling there's going to be a lot of people that want to come online all at once, and it might be tough to get everybody going at the same time. We also want to determine what type of system we're dealing with here. Is it a direct draw system, a kegerator type? Direct draw, maybe shanks right through the wall, or a long draw or remote air cooled, possibly glycol with that, as well as all the pressure parts and pieces. These things may have been sitting for quite a while, and we want to make sure that we're all back in business if that. If you're not sure about these components, ask for help. You can call us, you can call your local suppliers. Let's make sure we get this going right to be able to do that with that. So keg inventory, a lot of beer stories about beer being sitting for long periods of time. Is it expired? Some breweries have actually extended shelf life dates on that. Check with your suppliers to be sure on that as well. Inventory levels. If we get going, do we have enough beer to be able to tap this? Maybe we have 20 faucets, 20 beers on tap, but we only have enough beer to start with 10, stuff like that. These things will be questions to be concerned with as well too. Do we need to order from our suppliers? Are we able to get new inventory when we need it? And what we have is it sellable as well? Remember those first experiences the customers get, and if the beer's not good, they're going to be leave a lasting impression. So again, talk to your suppliers on that. A lot of the beer sales reps have had sensory training and can help out with that to determine if the beer is good or not, to be able to do that. The system itself, what was done to it? Anything, nothing. Was the refrigeration, meaning the walk-in cooler, turned off, adjusted? A lot of stories about things being simply turned off, turned up to do that, meaning where are those kegs sitting? Where's that beer at? The glycol itself, was that continue to run if you have a glycol draft system? Was it turned off completely? Was it the temperature simply adjusted up so water or left in the lines would not freeze. All these things that we need to be concerned about as well too. Okay, with that, getting the glycol going. Was beer or even chemical left in the line? A lot of stories of everything under the sun here. Beer left in the line, water left in the line, chemical left in the line. These things can be some things that we need to be concerned about with that. Was the lines clean prior to shutdown? There was several hibernation procedures that were put out by us and other principals to do that. Have we been cleaned every 2 weeks after? I have had some stories of people actually cleaning the beer lines in between their uses here to do that. So, and again, there is a deep clean process if we have a system that was sitting for an extended period of time or possibly in bad shape before all this happened. We can talk about that to do that. So chemical left in the lines for that long a time could have some damage on some tubing and any brass pieces that may have been in the system as well too with that. The picture on the right of the slide, believe it or not, that was a picture taken when the cooler was actually on. So we can even imagine if the cooler has been shut down to do that. So is it worthwhile to save this equipment, or is it time for a remodel of parts or pieces, or maybe even a whole system remodel or revamp here? The pressure system, the pressure side of the system. There could be gas that has been leaking for a while. We want to make sure to be safe with this stuff. CO2 alarms are starting to be more prevalent in walk-ins or where gas is located. If that had been disabled or turned off or unplugged, we want to make sure that we get that back up and running, turn back on, and heed any warnings that gives us if we do turn that off. Turn that on, excuse me, and proceed with caution. Gas buildup can be very dangerous in walk-ins, and bad things have happened to some folks as well. If there is no alarm present and we just don't know, we want to leave that cooler door open and air the building out if possible before entering. Give that cooler some time for any gas that possibly could be in there to get out of there. We want to make sure that it's safe to get in and make these changes and clean as needed. Pressure sources. We obviously, no gas means no beer. Famous saying of mine anyways. Whether we have just CO2 cylinders, we could have bulk CO2, we could have gas blenders to deal with, and even nitrogen generators as well. So we want to make sure that we have these gases, that they haven't been either leaked out or simply were empty when this was shut down as well. So we want to make sure the bulk CO2 gauges, some pictures of the gauges on the side there, depending on the bulk tank, usually somewhere they're going to be just pushing out at somewhere about 90 to 120 psi as well. They should have a vessel gauge as well, and if that's below about 120, that's telling you that you should call your gas supplier for a refill as well. CO2 cylinders, generally a CO2 cylinder at an ambient temperature is going to read somewhere in the 800 psi range. This cylinder with the regulator being shown here almost into the red zone is darn near empty, and you wouldn't get much beer out before that would go down, be done with that. Gas blenders, we usually have to have two gas sources when we have gas blenders, so we need to make sure our CO2 and nitrogen supplies are ready to be able to do that. I do have a CO2 the shutoffs on the blender as well here too. An arrow on the right side of the page calling off a shutoff that's off because the tube is not hooked up. We're not using that side at the moment per se. So nitrogen generators, if this is a piece that you do have or we have to deal with, again, was it unplugged? These do take electricity. If so, we need to make sure that it's plugged back in, and it should have a spare tank or a backup, and make sure that that's completely filled before we get back going here. Also, we would want to detect and repair any gas leaks possibly that we had found as well. If you're not comfortable doing this, and people sometimes are not comfortable with gas, just call your suppliers for sure, or a draft tech who's experienced in these gas parts and pieces. Secondary regulators. If we have are we using 100% CO2 or a mixed gas? We want to make sure that these are adjusted properly based on the system balance. It's possible that these were never even touched in the shutdown, which I think might be more than likely, but if so, we want to make sure that these are adjusted correctly. A lot of people do like to mess with these even on the best of days as well. Beer pumps, another part of the pressure situation sometimes. If they are there, are they on? Do they need to be adjusted as well? These pumps, if driving them with CO2 or a gas, make sure that that gas is exhausted outside of the cooler. Safety first here. Flow reversal valves on some of these pumps. If they have them, we want to make sure that they're in either the dispense or cleaning mode, depending on what we're doing, and we might be doing both here as well. So once we're done with the cleaning process, we want to make sure that that's put back in the dispense mode so we can push the beer out to the bar. Hopefully, this is not what the couplers look like when you get there. If the system was shut down properly and the couplers were cleaned and stored per some of the hibernation procedures, there shouldn't be too much to be able to do that. Just go and possibly inspect them to be able to do that. But if not, do they need to be cleaned? Were the keg couplers in the on position, literally still on the kegs to be able to do that? If so, we could have had gas leaks. The gas that's in the remaining beer, in the keg certainly could have permeated out over this length of time as well. Could mean flat beer as well. Was the coupler left on the keg but the handle lifted? That would have shut off the gas, so that shouldn't be an issue there too. So we want to make sure that is. If the couplers are seized, if they're dirty, we want to be able to remove, disassemble, and clean them. For sure, inspect any and replace any worn seals, probe washers, body seals. These things do fail from time to time, and this could be a time to inspect all that as well. And then also there's some probe rings highlighted to the right of the page here. We would, if we're going to repair these and refurb them, we'd want to make sure we would lightly lubricate those before reassembly. Makes for an easy coupling and uncoupling of the kegs when all these things are working. Faucets themselves, again, if the system was shut down and the faucets were cleaned, there shouldn't be a whole lot to do to get them ready, but even faucets that haven't been used for a while can be sticky and tough to crack open sometimes. So water is always our friend. Hot water poured on these faucets can really help them break any stickiness that might be on there as well. If they weren't shut down properly, we do need to remove them, disassemble, clean, to be able to do that. Obviously, if they've been left on with beer in them, it's going to be harder to remove, and again, water can help with that. That can take some time, so prepare to or leave some time for that as well. Any nitrogenated nitro faucets, we want to make sure that they're cleaned and disassembled as well. We want to make sure the spout and the restrictor plates have been checked and clean as well. If the system has fobs on it, we want to make sure that they're ready to go. They're clear for a reason, so we can see what's going on. So this might be a window into the system. If you see a fob that's very dirty in the walk-in side of things, that's going to tell you a lot to what's going on to that system as well too. So these things require normal disassembly and cleaning twice a year. They should be hand cleaned. Any O-rings or seals that are bad or need to be replaced should be done. This would be a great time to be able to do that. The fobs on these vents, very critical. They get stuck open sometimes when they get beer left in them. So we want to make sure that they're clean. We can do this during the cleaning side as well too. And then if they are plumbed to a common drain, we want to make sure that drain line condition is good. Sometimes these drain lines can get clogged as well too. Have had several calls over the last few weeks of techs getting in and didn't have time to clean the fob, didn't have time to replace it. They actually bypassed them. They just cut the lines and spliced them. We'll leave that up to you, but that was one way that I talked to 2 different techs that were able to get this going faster, and then they hope to replace the fob as soon as they can down the line. The beer lines themselves does the line. Maybe it's time to change that. A lot of short draw, direct draw, jumper lines out there in the trade. These things should be changed every year or so anyways. Maybe this is the time to do that. The easy access to these does make it somewhat easy to be able to do that. Could be a lot of 3/16 ID jumper line in a direct draw system, usually 3/8 vinyl jumper lines in a walk-in cooler. So even had some techs say changing the line was easier than cleaning it, and again, might be time to do that. Great time to consider an upgrade to a newer tubing like our Extra Flex Master tubing. Still has the flexibility that people want and need, but it is a better material than vinyl as well. The drip tray itself also want to make sure that's all ready to go. There hasn't been beer sitting in there, puddling in there, clogging the drain. Who knows what's going on there? So we want to make sure to clean that up. We could pour our cleaning chemical down the drain as well. That's a good drain cleaner to do that. If a glass rinser is there, make sure that the water is ready for that, and we could test that, make sure there's no leaks or anything. And also then glassware, the last thing on that glassware has been sitting around a long time. We want to make sure that that is clean and sanitized and ready to go. Now, let's get ready to pour some great beer. So I'm sure these systems are going to need to be cleaned, whether it's a normal clean or the deep clean that we'll talk about as well. But with that cleaning, we always want to make sure safety first here with that. And that goes without saying. The PPE, personal protective equipment, we've all heard many stories about that lately in the news, but we've always tried to push that at a minimum, gloves and glasses for protection as well. We always want to make sure we mix our chemical to the water, not the reverse. You have a chance of splashing that on you or something else. We want to rinse with fresh water, never beer. We want to also utilize pH paper or a pH meter to test for verification, making sure that we are rinsed properly to do that. Manage the location of the chemical at all times, meaning know where that is. We want to keep the cap on that. We don't want that bottle spilling over. I've kicked them over myself, moving down the bar and not doing that. So ideally place that chemical on the floor or in a bucket after you've got what you need. You want to make sure to prevent chemical sprays and releases. Sometimes the cleaning equipment can get worn out, clamps, hoses can get worn, as well as hoses in the system itself. So we want to make sure any defective clamp or hose could be that. We don't want to do that. And of course, we want to make available and follow all the safety data sheets with that. The principles, we do want to follow the industry standard line cleaning procedures, best practices here, at a minimum 14-day cleaning cycle. But to do that, we're going to purge all the system out of the beer out of the system, with water. We're going to use now a 3% caustic solution and make sure the water is the proper temperature, somewhere about 80 to 110 degrees Fahrenheit. And we want to make sure the chemical has contact time to do its thing. If we're using a recirculating pump, 15 minutes at a minimum is recommended. 20 minutes chemical contact time if we're using a static or a pressure pot system. Not necessarily recommended on long draw systems to use a static system. We need to make sure that all faucets are removed, disassembled, and brushed clean. We're going to flush the caustic solution with cold water once we're done until we're pH neutral. And we're going to then clean the system quarterly with an acid chemical to do that, to get some other stuff. And then we want to make sure we document what we've done, whether it's required at the bar or just for your personal knowledge. The principles of cleaning on the right side of the page. This is these are the laws of mass cleaning. If we want to make sure that we have enough contact time, the solution's the right temperature, it's the right concentration, and then agitation. If any one of these things is shorted, we need to extend one of the other ones, meaning if I don't have enough chemical, I may have to keep my contact time down. So we want to be sure that we're following these principles. So the beer spoilers, what we're going after here, what are we cleaning for? So basically 4 things that we're cleaning for: bacteria, yeast, mold, and beer stone. These bacteria, they're not hazardous to us, but they can impact the flavor, the taste, the smell, and even the appearance of the beer as well too, to do that. Some of the names are down below there. I know they don't sound very good, but they really don't hurt us, but they can certainly mess up the beer a little bit. So we want to get in there, dissolve, remove, sweep this stuff away as well. The bacteria, the yeast can lay down on the lines. Mold is generally in the cooler or at the faucets on the ends of the system, and then the beer stone is a calcium deposit, and that's what we would be trying to chase with the acid cleaning on a quarterly basis. Most common chemicals that we do use, what's called sodium hydroxide. A lot of people refer to these as caustics or alkaline. To be able to do that, we want to make sure that we're using this now in a 3% solution, meaning for every gallon of water, 3% of that gallon will be of a caustic nature. There are other chemicals out there that can be less effective, but we want to make sure that we're using what we should be using and follow the directions and the safety as well. The phosphoric acid, when we do that now to start things up, we're going to use that at a 2% caustic as well. And again, follow directions. If the chemical that you're using doesn't have know what it takes to get that, reach out to us and we can help with that. So again, the systems, the cleaning methods, 2 ways. Either what's called a pressurized or static soak containers. These are fine for direct draw type or short draw systems. There can be a stainless steel type can like in the picture below, a plastic pressure jug. I've seen many breweries where they actually just take an empty keg and fill it with some chemical and then go clean with that. And that scares the heck out of me because I never know where that keg is going to end up back in that brewery or whatnot to be able to do that. With a pump, a recirculation cleaning pump, this is a best practice for all systems. We should try to achieve this as well. How we're going to do that, we're going to flush all the beer from the lines with water. Number 1 is to get that beer out, okay? Or again, it could be water left over, who knows what was in there during the shutdown. So sometimes the toughest part of this can just be establishing the sequence. So we know we're going in the right order. I need to have these beer lines connected correctly to be able to do that. So in order to do this, we're going to have to take the faucets off, which I think is a good thing to hopefully clean them. We're going to link together all of the couplers in the walk-in cooler with some what we refer to as dual flushers or duplex couplers. To be able to do that, we have what are called jumpers that we're going to connect these things as well. So we're going to link the tower shanks out front, the kegs in the back. Out front, we're going to fill a bar sink or bucket. Make sure that bar sink is clean and your buckets are clean as well too. We're trying to get stuff out. I don't want to be putting anything back in to be able to do that. Then we're going to put water in there and push everything out. Then we're going to connect the coil cleaner to the left faucet in this particular slide I'm showing you. And the right faucet is going to be the drain line, and that's going to go down the drain or into a bucket or a sink as well too. Ideally, very important, every 2 weeks that we change our flow. Today I'm starting at faucet number 1. 14 days from now, I would start at faucet number 6 and reverse my flow. Very important that we do that. As well, a lot of these electric coil cleaners have adjustments for the pressure. We want to make sure that we're going at least a gallon a minute to be able to do that. The faster I push, the better I clean, but we have limitations on that. So I need to get all that beer out of the lines and turn off my cleaner. Now I'm going to mix my chemical to be able to do that, mix it up and introduce it. And remember the right strengths that we want to be able to do. We want to mix the chemical with water in the sink or the bucket to be able to do that. Now we're going to place both the coil cleaner inlet and outlet in the sink of the bucket, and the chemical water mixture will be pulled through the system as well. Now we want to be able to allow that chemical, once it's in the system, to keep circulating or recirculating for a minimum of 15 minutes. If you got longer runs, you may need even more time for that. We want to be careful how many lines we can do at once here. It's all about the scrub factor to be able to do that. Once my 15 minutes is up, I'm going to turn my coil off, drain my chemical, anything I have left down the drain, and now it's time to rinse. So step 3 is flush and rinse. And I want to, again, now use as clean and cold water as I can possibly get to be able to do that. I'm going to flush all the chemicals out of the solution from the lines with cold water until I'm pH neutral. So if I could test my water either before to be able to, I'm back to a pH neutral of 7 as well too. Once I've done and I've proven that I'm back to pH neutral, I can disconnect my coil cleaner, remove all my jumpers, take all the parts and pieces off the couplers, reinstall faucets, manually check for keg couplers, wipe down the beer lines if possible and necessary, and then connect the couplers and pressurize the system. And then now the new beer will push the water out of the system as well. There is another cleaning procedure, excuse me, that we might have to do if needed now because of the extended shutdown or a neglected system in the past for many years, or maybe even a combination of both that are going. This is referred to as our deep cleaning procedure, excuse me. This is going to require a recirculation pump to be able to do that. So we are going to clean the same way, but we're going to increase our chemical quite a bit. This is a very, it's a lot of chemical, so we want to be super careful with all this. This scares me, but this has been proven to revive some systems that have been neglected for a great length of time in the past. So now we're going to use 13% of the chemical per gallon of water. We're going to fill all the lines with our cleaning pump, and now we're going to simply turn it off and let it soak for 20 minutes. And then we're going to re-energize the pump, and we're going to recirculate now for 20 minutes to get that scrub factor going. Once I'm done with that, I want to flush with the freshwater flush until I'm pH neutral. I want to make sure I get all that chemical out of there. Then on the deep clean, we're going to make sure that then we're going to use an acid cleaning as well too. We never want to mix these chemicals, right? So we want to make sure that all of the caustic is out before we go to the acid step as well. Again, we're going to now up our chemical concentration to 6 capfuls per gallon or 6% per gallon of water. And now we're just going to recirculate that for 15 minutes as we would to be able to do that. And then I'm going to also freshwater flush until pH neutral as well. If soil is still present, if you can still see it in the lines, in the fobs, then we might want to circulate an additional dose of the alkaline or the caustic cleaner to do that, and a 15-minute freshwater flush until pH neutral. Again, this has been very effective in restoring neglected systems in the past, but I cannot stress enough, be careful with this. Please be careful. So the end result, what's it going to be? When we walk in the door, is this going to be what we find here? And if so, how are we going to take care of that? And hopefully, this is the end result to have that. I think I'm ready for one of those. I hope you guys are as well too. So I want to say thanks for the time. That's the end of the presentation today. But if you have any questions, we'd be happy to help with any of those. Thank you very much.
Hey Dave, thanks for all that great information. We do have some great questions here. One came in, I'm sorry, I published it here. A 12 product glycol system, now with only half capacity. They are not going to use all lines. That means the line must remain empty with just air in it. What are your thoughts on this?
Boy, half of the line's empty. That's a good question. We've always felt very comfortable having 1 or 2 empty lines in a glycol bundle. Having 6 in there, I'd almost think that would have to be an experimentation. We could just put beer in those lines and just not pour that. At least that would help transfer the cold in the empty lines. Glycol has been known to be used in empty lines as well too. So I think either one of those might be a good solution until we're ready, excuse me, for the other 6 lines.
Okay, awesome, thanks. Another question from Nick here. On long runs of over 120 feet, would you reduce the amount of lines you would clean at one time?
Yeah, most definitely. Depending on the pump, the strength of your pump, it's all about the scrub, right? That's the whole point of using the recirculation pump as well too. So sometimes if we already know, if it's an existing account, you know, if we can only do 2 lines, 4 lines, 6 lines, yeah, it's all about that flow rate. Beer generally flows at 1 gallon a minute, so we would like to be stronger, at least match that or stronger if possible. So a lot of techs I've been with over the years that just because the pump can go 700 feet doesn't mean it should, right? We're not getting the scrub action. We can do that. And you can simply measure that flow rate with water. I find that to be the easiest. As we're cleaning, just measure how fast the water comes out. And if you're getting a good flow rate, you might be able to do another 2 lines, Nick. If not, then possibly we can only do 2, 4, 6 at a time. Again, depending on the strength of your pump. Lots of different pumps out there. So know your pump, and we can help with that if you have any questions.
Awesome, Dave. Thanks. Great information. Okay, another question. What is the proper way to completely disengage the coupler from the keg?
A proper way. Well, I would just generally, depending on the type of coupler, most couplers are referred to as lever handle couplers today. I know there's a lot of, could be some older ones out there, wing style, but basically that handle, whatever it is, you're going to be able to pull that backwards a little bit towards you possibly and lift that lever upwards. And then we're going to twist that coupler counterclockwise generally, depending again where you're at in the cooler, to be able to do that. These couplers, obviously, sometimes they get put on over tight. They can be very difficult to remove, but ideally the coupler has about 1/4 turn on that to make a proper seal as well too. So again, now that these couplers could have been on there a great amount of time, they could be difficult, seized or glued or sticky beer glue, like I always say, to that coupler. So if you have trouble, again, water, hot water, if we can get it, we might want to pour some on that to help free up some stickiness there. Water's always our best friend cleaning.
Okay, awesome. We have another question here. Another question someone was asking, how do we know when a CO2 tank is empty?
Depending on the CO2 regulator that you have, generally you're going to have what we refer to as a high pressure gauge. Usually goes 0 to 3,000, depending on the temperature, the ambient temperature that the CO2 cylinder is at. CO2 is generally going to be somewhere between 700 and 900 psi on that 0 to 3,000 gauge. At ambient temperature, right? So we want to make sure that generally, depending, it really doesn't matter if it's a 5-pound, a 20-pound, or a 50-pound tank or something in between. The pressure reading is going to be the same because the gas is at the same pressure, right? So when that gauge, we did have a photo on one of the slides there of the needle almost being in the red zone. That red zone starts at 500, and basically that means that tank is dang near empty. So we can do that if the gauge is all beat to heck, which a lot of them are. I have actually had people put it on a bathroom type scale. That's another way we could see if we have any gas. Again, if our gauges are broken, hopefully we could replace the gauges. Maybe a brand new regulators in a store. I would happen to know where we could get some, but a great way to do that. That's why those gauges need to be in good functioning order so we can see where we're at, both the outbound pressure and the remaining gas that we have.
Okay, awesome. One last question here. It says, how do we prevent lines from freezing? Okay, so
freezing, you know, if And I have even a personal friend of mine shut his bar down, and he left water in them. Once he told me that, I told him to get that out of there. But water obviously will freeze at 32. The glycol settings on these machines generally are going to be lower than that, somewhere 28 to 34, 35, depending on the manufacturer as well. So water can freeze if left in there long enough. I find most of the times I hear about freezing lines is when people are using the static type cleaning method, meaning they just put the water, the chemical in there, and it sits and soaks. Chemical has no antifreeze value, so it's still going to freeze at 32 to do that. That's why I'm a bigger fan of the recirculation cleaning. Water that's moving will not freeze, right? So as long as we're cleaning, some people prefer to turn the glycol off during the cleaning process. I do not particularly do that, but I've always been a fan of that. As long as we can keep that water moving, it's not going to freeze. If it has frozen, we simply have to turn the glycol off, let it thaw out, and hopefully that's a lesson learned.
Okay, awesome. Well, thanks for the great information. Everyone, just so you're aware, we will send a copy of this presentation, a recorded copy, to the email that you submitted your reply back to. We really appreciate you tuning in today. Thanks for all the great information, Dave. Everybody stay safe and have a great day. Thank you.
Yeah, thank you all.